Hello, I have arrived, and welcome to the stream. Hello, Witherstorm. Hello. No, this is playing back. There we go. Alright. So, in this stream, I'm going to be making a program to interact with Minecraft GUIs. So, it's basically just going to like manage inventory stuff and be able to craft things. So, we'll see how this goes. Okay, first thing we need a program to capture the Minecraft window and take screenshots of it. So I'm gonna open this up, which I already have open, I think, over here. Yep. And this is going to take screenshots of Minecraft. So don't worry about it. Just some magic code. 32 con. Okay. And I know the width and height of the Minecraft window, the width and height is 958 by 493. Because I already did this before, but what you can do, you can screenshot the entire thing and then open up Microsoft Paint and paste it in, and then you can get the measurements from here. So like this coordinate and that you can work it out. That's how I worked that out, but that doesn't really matter because I already have the values. So I need a function to screenshot Minecraft. And this is just using the Win32 library, Python, just to be very quick with screenshotting. Because I want a very fast screenshot method so I can repeatedly screenshot Minecraft and like update it quickly. Just so I don't have to wait very long. Other screenshot methods are very slow. And this thing is going to find Minecraft based on the window title, which I think is like this single player, because this is the title of the window. So this line is going to get the window based on this title. And then I need a system to get window DC. This is all very confusing stuff. I don't really know what half of this stuff is because it's interacting with windows at a very low level. But like, should work. So Win32 UI, create DC from handle. And this is basically all just to get a screenshot of Minecraft. So screen DC object. Alright, this is okay. Now we can actually get the image of it. So we're going to go data bitmap equals win32ui dot create bitmap. It's going to make a bitmap for us, which is just an image. And then data bitmap dot create compatible. This be DC object width height. So that should create a bitmap with the width and height that we need, because that's the Minecraft window size. And then we need to do cdc.select object. That's a capital S. Object data bitmap. So that will select that, and then we got to like paste the screenshot over there. So blit, cannot spell. It's a bit blit. Bitmap blit, and then we're gonna paste it at 00 with height, and then the actual thing is the object. And then this I think is the offset I set before. And then win32 con dot source copy. Okay. Now I'm gonna save it as an actual PNG image. So data bitmap dot save bitmap file. And don't worry, this like I know this probably looks really boring, but like I only need to do this once because it's just the boring screenshotting bit. And then we'll actually get into actual fun stuff. So I'm going to save it as screenshot.png, and if we have an issue, I'm just going to display an error message. So error, something bad happened, I ignored it in the worst way possible. because occasionally this errors out and I'm not sure why. So what I'm going to do is I'm just going to recursively call the function if the error is out, which is not a good idea, but like it works. So I can clear everything from memory and just to release it. Would it create files in the same name? Yeah, it's going to repeatedly create one file called screenshot.png and it's going to update it. So it'll like overwrite the existing file if it's already there. And I have to delete all these objects from memory, otherwise you can fill up RAM very quickly. And it's good to close these objects after you're done with them. Now I'm going to open the image up with CV2. So cv2.imread screenshot.png, and I'm going to return the image that I just opened. Now if name equals main, so if we run this program as the main thing, we're going to go import time and let's select image to give it a start. While one im equals screenshot Minecraft, cv2.imshow Minecraft. This will be the image. cv2.waitKey 1. Alright. And if I run this, should open up a window which is capturing Minecraft, even though Minecraft isn't even on the screen. So that's the benefit of using it by that window. And you can see it's very high FPS. So it's tracking quite well. You can see it's just loading this. Haven't actually had any errors yet, which is a good sign. But you can tell this is what we're going to be using to read inventory slots. So the program up here, this is what the program sees, and it's going to be able to screenshot this and work out where items are, where items need to be for crafting recipes and stuff. So it'll be able to do stuff. So like this is just a screenshot, like a live feed thing of Minecraft to the program. Now we need to actually import some kind of screen reading system. So I'm going to write this out, and basically I want each slot to be handled independently, and the program will just process each slot and find out what item it is and how many items there are in one slot. So that shouldn't be too hard. Yeah, it should be alright. We should be able to do this. Okay, so now I'm going to make a new folder, call it UIs, because things like crafting tables and double chests have different positions of this. So if I show you this, the inventory on a double chest is down here. On a crafting table, it's up a little higher. So the program needs different like setups to work out where each slot is. So it has to figure out like where each slot is. So I have to specify that. So I'm gonna make a new file, call this crafting table.json. And this is going to track the data for crafting tables. So there's one. I'm going to set this up like so. Container slots, and this is just how I'm going to define each inventory type. So I'm going to set up a type, which is area, size of 3 by 3, because I'm defining this inner area of the crafting table, this 3 by 3 square. And then I know the coordinates, the pixel coordinates from the top of the screen. I can just type chords. 360 and 112. So that is the offset from this pixel to this pixel here. And now I have that, so I can just copy this, paste it, and we need to get this region of the inventory. So I'm going to go area, size is 9 by 3 because that's x by y. Inventory is x, like 9 by x, and then 3 in y. So like that's correct. Offset will be 316 at 256 because that's the offset from here to there. Again, same thing as the crafting table, as the grid square, and then this one will also be area. It's that, and this is 362. So this is the hotbar of the inventory. So now I need a new file, and this will be called crafting table.py. And this one, I should probably call it screen underscore crafting table. Or I can make a new folder and put them all into screens. Actually, I should be right. Okay, this is the crafting table screen. And in here we need to import the capture thing we made earlier, so this program, which takes screenshots. And then we also have to go crafting screen equals, and then we need something here. So I'm going to make a new file for this inventory screen.py, and this needs to be able to load textures and container slots. So this program needs to be able to read this format of inventory data. So in here, for Json, CV2 we might not need it actually. We can just use Json. For NumPy, we will actually need CV2 for image reading, so scrap that. And then import pickle, because I don't know. Probably need this for reading and writing some data later, just to like store textures and stuff. So slot texture size 351 minus 316 plus 1, 281 minus 246 plus 1. And this value here, if I just put this, is 36 because these texture sizes are 36 by 36 squares. So I'm just tracking that value here. And then we need to open a file which doesn't yet exist, numbers.pkl, read binary. Just going to load in number textures, because obviously we need to be able to read how many items are in each slot. So we need to track what numbers look like, because it only has access to images, so we need to load this in. Load numbers.pkl, fix the textures. Alright. And we also need to track image textures. Where do you come up with the ideas for your live streams? I don't know. Just when I'm bored, I think of something to do, and then I decided that it was a good idea to live stream it. Hello, hand programmer. Welcome to the stream. What time is it here? It is 12:42 p.m. Will I take part in the adult making jam? Probably not. I just don't really feel like doing that. Seems pretty pointless, but like, yeah. By the way, this function is going to match like two images. So it's going to check if two images are the same. And then this function is going to work out. So it's going to return the match of the number and the image. So you're going to give it a little image and it's going to work out what number it is based on this data file. So this data file is going to contain all the numbers. And then this function will just decide. It'll just return what number it is. So I can use the same function for matching images of items, and the dictionary match, and then textures, because these two dictionaries are in like the same format kind of, so I can just pass in that and it should all work. I need a function to load the Json UI, which is like this file that I made earlier. So this one we'll load a UI, a JSON file. And now we have to open the file that we pass in, because this is one argument to our function. So we're going to open this in reading mode as file buffer. So this is the variable which is the actual file, and then file data equals file buffer.read. So we're going to read the data of the file, and then we're going to load it as JSON data. So this is going to convert this string of data into an actual program readable variable. And then this will return the JSON data. So that's just going to load in the JSON of the file. Then we need another function to get the container slots. So this will be given UI screen JSON, a screenshot of the actual screen. And then this function will just be used for debugging this argument, draw rectangles. So this will process the image data of a screenshot, index item info of each slot. Process screenshot equals screenshot copy, because I don't want to edit the current screenshot. I want to copy a new image of it. So I'm just going to duplicate the image so I don't edit the original. And then container slot info should be a list. And then iterate over all the entries in the container slots list of the UI slot data. So this is going to loop over every single entry we have here. So like these things, it's going to iterate over those. So we're going to go for entry, UI screen JSON, and slots. Because this whole thing is this file, so I'm going to get just this list, just this bit here, and then we're going to iterate over each element in this list, which is like these. So if the entry type equals slot, this is just one slot. So like these types are only areas for the crafting table, but like I could need a single slot one. So I'm just going to do that. Then entry type will be area. So it's going to redefine entry type as area. And it's going to set the entry size to 1 by 1. So this just makes it easier to handle. So if it's a single slot, it's just going to set it to an area of size 1 by 1, which makes sense because that's obviously what a single slot would be. So this just allows us to process it easier. And now if entry type is area, start position, this is the iteration position. So I'm going to iterate through each slot. So this will be the top left coordinate. So like for this thing, we're going to start iterating here and go across. But I think I do y by x, so I go down like this. So I'm iterating from here down and then up and down and then down. And the area size is the entry size. So in that case of the crafting table grid, it would be a 3 by 3, which gives us 9 slots to iterate through. And then for tile y, hello Waylin, I'm not sure. You can use Python in Minecraft. No, you cannot. I'm just using Python to automate a GUI. So it's not actually in Minecraft. I'm just using Python to take screenshots and move the mouse and stuff. I think I can actually use editor tools. Import editor tools. So this should be a little bit better. The tile position in editor tools got product. I think I should use permutations. Length permutations. Range 3. I can probably use product. So this will be range area size 0 and range area size 1. Oops, pass. I missed the P. So it's going to import, like, use Python in the command prompt. And then I want to test out how this GitterTools product thing works, because I think it's correct. GitterTools.product range 3, range 4. That should be a list though. Zero, 1, 0. That should be X and that should be Y. Alright, I think it does work how I think it does. So it basically creates like coordinate pairs based on the X size and the Y size. So we're return 0, 0, 0, 1, 0, 2. So it's just going to loop through. Alright, so that should work. So I can just go tile X and tile Y. And then I can just like unpack the tile position. That should give me the X and Y coordinates of the tile. And then slot tile coordinates is just the tile X, tile Y. So tile X, tile Y. Or I guess it's already, you just do this. So that way it's already one thing, so I don't need to worry about unpacking it or repacking it. So slot pixel coordinates, because currently we only have the tile coordinates, which is like 0, 0, 0, 1. So this would be x0, x1, x2, y0, y1, y2, which isn't very useful because we don't actually know where that is. We just know what index it is, so it's not very helpful. So slot tile coordinates, 0 times slot texture size, 0. And what this will do is it will multiply tile coordinates by these values, by the actual slot texture size, which is 36 by 36. So this will get the actual pixel coordinates relative to this position here. So this one will be at 0, 0, this one will be at x36 and y0, and this one will be at like x36 times 2 and y0. So that's what we need. And then over here we need to crop the slot. So crop slot region equals process screenshot slot pixel coordinates 1. So this is the actual image file here, and we can use this to crop a region of the image. So it's going to crop from here in the Y, so like Y position, and we're just going to crop out the slot texture based on the actual size and position of it. I don't know if that made sense, probably doesn't. Not very good at explaining things. But basically this is just going to crop out the texture, so it's just going to crop out like this square, or this square. By the way, what does the title mean? I'm going to be automating Minecraft GUIs. So like auto crafting, inventory sorting, stuff like that. That's what the title means, since I'm using Python to do this. So alright, and we need to work out the like count of the items in each slot. So if I grab out some random items, redstone torch, and we have a bunch of redstone torches, and you can see the count of the item is in this little area down the bottom right of the image. So like that 16 is in the bottom right. So we need to crop out that area. So item count identifier is the actual image cropped. So this will be the cropped slot region. And then we need to get the slot texture size, 1 divided by 2 plus 2. And then this is just cropping out a little area. It's just going to crop out like halfway here and like 2 pixels off that way. Doesn't really matter, like all that. All that matters is that it crops the right region. So there, and then to 12 by minus 2. So now I can convert that image into grayscale. It's easier to manage than RGB. So cvt.resize, and then we have to recolor this image. So cvt color item can identify, and we're just gonna change it from blue, green, red into gray. And then the size we need to scale this to is 11 by 7. 11 by 7, there we go. And I should probably comment all this stuff so I know what I'm doing. So the actual pixel coordinates, big slot, this slot, and then the cropped image of just this slot. And then the count of the items in the current slot, a cropped image, and then the resized and grayscale version of the count image. Okay. So now I need to mask the texture. So cvt.resize. Well, actually, I can just do numpy. Numpy is great. Okay, what is the actual color of this white value? I need to get this white color here, so I'm going to select it. The eyedropper, edit colors, and this is 252. So that's the grayscale value. So this should be grayscale equals 252. And then it's between 255 and 0. Okay, and this number here, this image, will be the cropped area of this first value, so the value in the tens place. Because if we handle the tens in one separately, it's much easier to process the number, because then there are only like 10 combinations for each value. So it's a lot easier, don't worry about it. And then item count ones. So this is just the units place, which is 7. This is a y by x. So this will just crop out the second number. So this first one is the first number, and then this one is the second number. I can actually save this just so you can see what it's doing, because it's probably not very obvious. So if name equals main, I'm then going to run the actual program. So this will load UI, so screen equals load UI JSON. Table. And we're going to get container slots. And we need to screenshot the screen, so we need to import capture for that. And what's the two? I'm going to screenshot Minecraft, and this doesn't matter, but I can set it to true. Currently doesn't do anything. Okay, so now I'll be able to actually demonstrate what this is doing. So in here, I'm going to make a new folder for this slots, and then in the slots folder we're going to write cvt.inwrite, and then file name, x and y. So slot tile coordinate 0. Or I guess I can just write this to an actual file. So I'm going to write this file name will be 10.png. I'm just going to write the item count tens to that file. And I'm going to put this item here. So it should return a 1, or it should look like a 3 there. So if I run this, pretty sure it's the inventory screen file. Okay, I don't have the numbers thing done yet. Okay, I need to actually make that first. So I can not open these. Okay, that should be correct, and then I can also not make those functions, since I don't have either of those files yet. Okay, that should have worked now. Run this, open Minecraft, and it made a tens picture. And it is black, which is not good, probably because it's loading, it's going a different way than what I thought originally. Meaning it's probably cropping the wrong area, or it's doing something strange. Okay, I know what's happening. The slot pixel coordinates are off. So I didn't actually add the start position, because currently it's doing it based on like this area up here. So it was like scanning slots, but it really should be starting up here in this corner. And like this corner for each area. So now it should work. Run the inventory screen, open this up. Okay, here we go. We now got a 3, because that's what it screenshotted and then cropped. So that should all be correct. Image size is 5x7, because that's all it needs to be. And then this is 255, yep, alright. Okay, that is what we need, and that is what we have. So now I need to get each different value. So 1 or 1. Okay, so now I need to actually make that numbers file, which contains all the different combinations. So there's a 1 there and a 0 there. And we need a 2, 3, 4, 5, 6, 7, 8, and a 9. So this is every combination, every single number that it can be, but there's also a no number if there's like a empty thing. Now I'm going to not comment out all those because then Python can't read it because there are comments. So I'm just going to delete these, and then I have to save these files individually. So I'm saving the slot file coordinates. So now this is every single number it can be. Well, these actually need 10 slots of them. I need the 1 slots. So I should be saving the 1 instead of the 10s. There we are. So now we have every single possible number. So we're going to call this underscore 0, underscore 2, underscore 3. Should be a 3, not just an underscore. Alright, so now that we have these images, Python can then match them to work out how many items are in each slot. So like 6, and then 7, 8, 9, and then we need one that's none. So I can bring that back. Actually, I have to leave it out. And size should be 1 by 1, and then we'll just put in 1 item. Because 1 item actually has no number, which we need, so we need just that fully black texture. And save this, and then run this. we now get this one, which should just be under none. It should be fine. So now this none texture is just fully black, and then these are all the actual number images it can be. Okay, now I should probably do this before I lose that. There we go. Alright, so now we have the numbers we need. So we need to actually generate that numbers.pkl file. And I have done the numbers thing before, so I'll just open up that file. So if I just new file numbers, that's not the right data. I can't copy that. It's binary. Never mind, I'll have to make this myself again. Okay, so these numbers and textures, I'm just going to buy the textures one because I don't have any textures yet. But this should be a dictionary with each key corresponding to each image. Dictionary K. Return match. Okay. This should be correct. So I just need a dictionary which has the key and then the value. Alright. Shouldn't be too bad. I'm going to make a new file and call it generate numbers, or I'll just call it pkl underscore numbers I. And this one will be import unify, import cv2, import pickle, because pickle is what we're using to actually save data to the files. So the numbers file is going to be this. Paste that a bunch of times. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, and these images, these will be the actual image data of like each number, so it'll be all these images here. There are not many people watching right now. 5 people watching, probably very boring. cv2.imread, and we're going to read up, like open up these numbers and read them. This will be none.png. That's what we named this one. And then from here, can read in the 0.png, 1, and then 2, 3, and so on. Can delete all these. 5, 6, 7, 8, 9. Alright, so that should be all the images. And then I'm going to dump the file. Numbers. And then the file will be the numbers.pkl. And that should actually be all we need to generate this number file. If I run this, it is now here. And if we run the inventory screen thing, after I do this, so now we should actually be able to match the texture to what we have in this file here. And this is just like byte data, but it's what we need. So that should be correct, and it should all be right. So now I can work out how to actually identify this. So number in the tens place, just which number, I count tens. So this will just run the which number function, which just matches the image. And get the one in the tens place, and then this one will just be the one in the ones place. 0, 1. Alright, and then we can work out the real number, like how many there actually are in the inventory slot. So this one will be number 10 will be equal to none hello Makoto. Pronounce that other. I'm not very good at pronouncing names. Okay, let's just display these numbers as debug messages in the screen, so I'll be able to see what's happening. So if I run this with a bunch of items, hello Phantom MC, welcome back. Right, there's no all because I did something wrong. All has no attribute all. The dictionary matching function is not correct then. I'm just going to print out what V and V equals. So KT and V. Target is what we want to find. V is the actual value and K is the key. Well, that should work, considering the fact that these are images. What if I just do this? T equals V. I just check if they're equal. It thinks there are no items in any slots because it's returning none. For some strange reason, I might actually just copy the old numbers file that I had before. Or this should all be correct, so I'm not sure why it's doing that. Like this generating file. It really should return a NumPy array. And then we dump it. Alright, I'm just gonna use the one I made before. I'm pretty sure it's the same thing, but it might not be. I'll load it up and see what the difference is. That way I can figure out why it's not working. So this is the old one. Let's replace that one. I hear Minecraft music. That's playing music now. Alright, here is the numbers file. So I'm going to call read numbers. And then this will just open that file up. So read binary numbers, and then we should be able to print data. And data should be a dictionary of the number files. The 0 element, is it possible to do this on an iPhone/Android? No, it's not possible. Hi, what is this? This is a program I am making to interact with Minecraft GUIs. So it's basically going to be like able to autocraft stuff. And it's going to be able to sort inventories and stuff like that. Okay, this looks correct though, because like these are images. And they are 0 image, 2, 3, 4. Or I guess there's no none here. Yeah, I'll just use this one, it's fine. It sounds complicated. It is a little bit complicated. Yes. I'm going to match all of them and they should work now. Alright, it almost works, but that's just because I changed this, but we can see we have 3 here, and in that slot we have 33 torches, which is correct. And then the next slot over we have 4, and then the one after that we have 4 as well, because it's all one above. Yeah, and there's 2 there, so it's kind of working, but like it's still returning none a bunch of the time, because I am doing this. So here, it will return none. Okay. Will this be compatible with Bedrock? No, it won't. Because Minecraft Bedrock Edition doesn't actually let you interact with the window for some reason. Like, I couldn't figure it out. It's something to do with how it's a Windows app and Python doesn't like that or something, I don't know. I'm not really sure why that is, but like it just doesn't work. But I'm pretty sure this thing is working, so if I run this again one more time to double check, that will be the first slots, and then here we have the inventory slots when it gets to 0, 0. X, Y. Alright, we're actually doing it this way. For some reason it's looping through that way. So these are the first 3 slots down, which is none, that's correct. And then we have a none because there is no image there. And then a 3 and a 2. And then we have none, and then a 5 and a 6. And then none, and then a 33, and then a 4. Okay, it is actually reading this correctly. It is getting the right numbers out of it. So now we need a calculation to check what the actual number in the slot is. The real number will just be the tens place plus 0, if not number 0 1 else. But 0 1s. Okay, so this will return the actual integer number of how many items are in the slot. I wonder why I was doing it in Bedrock Edition. Yeah, I tried doing it in Bedrock Edition, but it didn't work, so I didn't want to use that because obviously it's broken. I wish I could do this in Bedrock Edition because I use Bedrock Edition personally a lot more than Java Edition. What happens when you resize the Minecraft window? It won't get the correct pixel coordinates. So I just use the Windows key and right, and that basically aligns it. So if you just lock it to there and then down, that's in the right coordinate. So I've set up to use that coordinate. Just for like testing purposes, and then later I can reassign the coordinates. Okay, but it works out that there are 0 items in the crafting grid, because this is the whole crafting grid area. And then this is the inventory going down from here down like this. So 0, 0, 0, and then 0, 3, 2, and it thinks this is 0 and then 3, 2, and that is not 0 though. So the reason it thinks it's 0 is because there's no number. So the program immediately thinks it's just not an item. So we need to fix that. And the way we have to fix that, we need to define textures for the item. So now we need the program to identify textures, which will not be fun, but I guess we have to do that. So item texture identifier. So we're just going to crop the slot area again, like the image. And this is the same way we got the item number identifier thing. So we're just going to use this and get the top half of the texture this time. We do -2. What do you mean, wait, what? Okay, so now we can probably rescale the texture just to keep file size down because we don't need the full texture. cv2.resize 16 by 7. That comma. And then I'm going to also convert the image into grayscale because I don't need to see the actual colors of it, because that's just useless extra data. We can obviously identify item textures based on grayscale. Wait, what do you mean? You can use other file types on UIs. I'm confused. What do you mean other file types? What are you talking about? Okay, so the grayscale texture will just be rescaled texture and then just convert it to grayscale. Wait, I'm not actually like doing, wait, what? No, I'm not making UIs, I'm making a program to handle images and stuff and like manage inventory in Minecraft. I'm not making like Minecraft UIs. I don't know what you're talking about. Yeah. Yeah, nah. Alright, anyway. Back to this. So we've made the texture grayscale, and then I can mask the texture to remove the gray in the background. Grayscale texture equals 139, 0. What are those torches, lol? I think this title of the stream is fine. Minecraft GUI automation using Python. Oh, apparently everyone's being confused by the title. Why are you being confused by the title? That's Java Edition. Yes, it is. Anyway, back to this. Texture equals which texture? I'm going to pass it in the masked texture, and I can also comment this. Okay, now I'm going to make an empty dictionary, and then I'm just going to dump it into the file. Okay, so now we have this new file, and it's just an empty dictionary. It's only 6 bytes, so it's very small, because this is going to store all the item textures. So this is how the program will identify textures. You can probably delete those numbers as well. That was satisfying. Alright, anyway, so that file is basically like the brain of the program, how it recognizes textures. So now in here, so if identified texture equals none, that means the program doesn't know what the texture is. I can just do is none. Then cv2.imwrite unknown slot. So we're going to save this slot as an image, and then we're going to ask the user what texture it is, like what item it actually is. I have no idea what item this is. It's helpful. And then we're going to go check unknown slot.png and tell me what item it is. And then the new item identifier be input, so we're going to ask the user for input, and then enter the item identifier, e.g. abandoned block So this is how we ask the user to add items to the database of item textures. So this way the program will know next time. So now I'm going to save it. Textures, new item identifier will be equal to the mask texture. And then we have to actually save the file. So open up textures, textures.pkl file, which contains all the image textures, and then write it. It's going to dump the data that we just edited, which is textures, and dump it into the file. I updated my textures identification. Okay, so now the program will know for next time. And then the identified texture equals new item identifier. And if the real number equals 0 and identified texture is not equal to empty, so basically if there is an item in a slot and the count is 0, the count should obviously be 1, because if there's an item there, that should be one item. So now real number will be set to 1. And then that's pretty much all we need. We can just append that, so it contains slot info.append slot pixel coordinates. What this should probably be. Yeah, that's the actual pixel coordinates of the slot. And then we need to append the item in slot name, which is actually just the identified texture. And we need to append the count, which is the number. That should be correct, and this should return container slot info. So now I can actually debug this, and we should get all of the slot information with item textures data. So slots, print slot 1 and then slot 2. This will print the item identifier and the count. So if I run this over here, it probably won't know what anything is. It says I have no idea what any of this is. So this one is called empty because it's an empty slot, and you can see here that texture. So I'm just going to press enter. And now it doesn't know what this one is, and this is a redstone torch. Just type that in, and now it can work out every item in the inventory because all we have are no slots and redstone torches. But still, it worked out there was, this is the main inventory. This part here is starting from here and then going down and across. So we can see that we have 1 redstone torch, then 2, then 3, then 1, then 1, then 3. Here it works out we have 16, and then there's a 1 below it, and then 22, and then 2, 2, 2, 3, nothing, nothing, 1. Yeah, it seems to all be working. So now that we have all this data, we can sort the inventory based on whatever we want, and we can use the program to move items because it knows the pixel coordinates. So I'm just going to add a bunch of items to the database, like redstone stuff, redstone block, copper, I don't know, like iron ingots, diamonds. Doesn't really matter what we're adding. It's just so that next time the program will know what all these items are. Now I can run this and then open this up, and it doesn't know what this is, so it's just a plank, oak, plank, or I can do like plank underscore oak. I'll do that, plank underscore oak. And this one is redstone. This one is repeater, because you can see over here this texture file is just what I'm naming them. Repeater, comparator, comparator. Is that how you spell it? It is. And this one is a redstone block. This one is a hopper. This one is a diamond. This will be an ingot. This will be coal. And this is a stick. So now it knows everything in my inventory. And then obviously next time if you have an item it doesn't recognize, it'll just ask you to verify what it is, and then it'll remember it for next time. Okay. Now that we have all of this information, we can do a lot of things. Okay, that's correct. I can delete this file and this one because those are both unnecessary. Alright, so one thing we want, I want to be able to open chests and put items into chests. I think that's more important than crafting currently. So this is the inventory of a chest. You can see it's a little different. The crafting table doesn't have the same areas. So here we need to work out sizes and pieces of this chest. So this is going to be called chest underscore single.json. And in this file, we need to define basically the same as this crafting table, but with this one different. This will be 9 by 3, and these coordinates are 316 by 112. And this is the new file which defines the UI shape of this chest. So these are like the coordinates and the area size. Same thing I did for the crafting table. I'm just going to copy this, paste it, and rename this one to screen underscore chest underscore single. And now in this crafting table one, I need to, actually that should be it. All I need to do is load in the other stuff. So import inventory screen. This one will just be inventory screen.load UI JSON. UI is crafting. Spell. Now just use this same thing. Same single. Alright. So now we have both of these which contain all of the information. So we make a new file and call this inventory extras.py, and this file is going to manage like the math behind moving items in your inventory, like adding up 2 slots together and then counting how many there are in the added slots, and then like summing up how many items you have in total and stuff. So we need to work out that. So we need a function to ignore all the empty slots in a container. So we're going to return list for x in container. Container, if I can spell, if x1 is not equal to empty. So basically this will just return a list, which is the same thing you input except without all the empty slots. So it will just ignore all the empty slots. And then we need a function sum container contents container sum equals that. And I'm just going to redefine container all of like container 2 equals ignore empties container. So it's just going to force to ignore all the empty slots, and then we're going to count up how many items we actually have. So for slot container item name item count equals slot, and then this is just to ignore the pixel coordinates of the slot because we don't need that for this. Summed item name item name equals this item count. So basically this is just going to add 1 every single item it sees, or like add how many there are in a slot. So this is just going to count up how many items we have in total in an inventory. Then we're going to return this sum. So now in this chest single system, I can go if name equals main. We can then work out how many items we have in total. So I'm just going to use import inventory extras. And then I'm just going to copy this system where I actually load this part. Just going to use that. So now we can screenshot the screen, and then we can count how many items there actually are. We're just going to use this as the chest screen. We'll just rename that one to screen. Also rename this one to screen. Now I can just pass this thing in, and get container slots should actually be in screen.get container slots. And now I can go sum equals inventory extras. Got some container slots, and we can pass slots. And now we'll be able to count how many items we have in total. And then once we have this, we can work out how many recipes we can craft of stuff, and we can do all that cool stuff. We can do some very cool stuff with this. So what we need is we need to display this information so I can tell that it's working correctly. I'm just going to go summed contents equals, well, we already have the sum contents actually. Max length equals max. And it's just going to work out what the maximum item identifier is, just so I can display it neatly. And then for kb in summed items, I'm then going to print this in just like a neat format. Okay, so now if we run this, run the chest single, it should find nothing. Sum contents empty equals 0. Or actually, it should even be finding empty. Did I actually run this? No, I didn't. I'm using the other container. There we go. Now it should have nothing in the inventory. If I run this, yep, there is nothing here, which causes an error, but that's fine. And if I grab out iron and diamonds, just have like 33 diamonds and like a stack of iron and just distribute it everywhere randomly. I have 33 diamonds and a stack of iron in my inventory. And if I run this and open that, it thinks I have 44, but because my mouse was over it, if I rerun this, the mouse was in the way. Oh, no, it sees 44. 44 and 33, so something is going wrong. Because I know I have a stack and 33. That's correct, that's not correct. That's probably because there is a white pixel in the iron texture. Let me screenshot this and find out. That pixel is probably confusing it. This one here. Or this one will be confusing it. That pixel is 252. Yeah, that's the exact same as the numbers. So we need to fix that. And that's obviously a problem that we occasionally run into. So what we need to do is we're going to go into Minecraft, options, resource packs. We have to make a resource pack for this, which I already have. I have my UI automation one. So I'm just going to open vanilla, assets, textures, item, and we need to find iron ingot. I'm just going to copy that and put this one into UI automation. And sugarcane also, like sugar also uses that white value, which confuses the program. So I'm just going to do this, just darken the texture, I guess. Or I can just use some paint on that, it's easier. Or I could obviously use a program to darken all the textures, which I guess I can do. Hue saturation, just going to decrease the texture brightness. And that should be fine now, so if I just reapply this pack, I don't think I reapplied it. Resource packs, take it off, it's done. I might actually just use a program to do all of the textures at once. Because that way I don't have to worry about that white value. Now, if we load back in, iron is darker, that's good. Run the inventory screen, actually run the chest one. Run the chest one, move the mouse. No idea what this is, so I'm just going to redefine if that's iron ingot. Now it knows we have 64 iron ingots and 33 diamonds, which obviously isn't that hard because it can just like see them right there. So if I just spread them out randomly, and run this, 64 iron ingots, 33 diamonds. So it is once again working, and all I had to do was just make the line darker, because it is that annoying white. So now what we can do is we can set up auto crafting. Or we can set up chest sorting. Depends which one you want me to do first. Just like comment in the sidebar and I'll see. So if you want me to do auto crafting, just ask for that and I'll do that. Or if you want me to do like chest sorting stuff, I'll do that. So I'll just wait for a reply. Actually, another thing we need is we need the program to be able to work out how many items stack to. Okay, chest sorting would be good. That's good. Alright. So I need a file which contains stack sizes for each different item type. So Python for pickle. So again, we're just going to make an empty dictionary and call this item stacks.pkl. Okay, now I have this new file. Alright, so this is going to track how many each item can stack to, because obviously iron ingots and diamonds can both stack to 64, but ender pearls, when they stack to 16, eyes of ender stack to 64, and there are like other blocks and items, like obviously swords only stack to 1, little shells stack to 1, enchanted books stack to 1. It won't be able to recognize enchanted books because the texture changes, which is just annoying, but like, yeah, snowballs also, yeah. Just things like this, totems. Just any kind of these items, which can be quite painful to deal with. But it should be alright. Shouldn't be too bad. Or actually, another fun thing I can introduce. If I spawn in some mob, never mind, I'm in peaceful. Some peaceful mob. Cow. Alright, now let's go for survival. Stop running. I want a way to work out durability of items, if they have durability. Alright, see ya. Okay, so you can tell this item is a bit used down, and I need a method to figure out how much durability is left. I'm just going to use it down a little bit more. Definitely not just like killing cows. Okay, there we are, and now I'll switch to the game mode creative. Alright, so we have that item, which is worn down. And a way we can do this is we can crop this texture. So we just have to crop the durability bar and then work out how much durability is actually left. Alright. I think I know a way I can do this. But for that to work, I need another file here. Actually, use a program to generate this one, and this will be item durability dot py, and this will be a true false thing, which will just return. So this will be item durability. I guess it should also be a dictionary. Okay. And this will be like any kind of sword needs durability. Wooden sword. Should set this like sword underscore wooden. Wooden swords have durability. Stone swords have durability. Gold swords have durability. Blah blah blah, you get the idea. I'm just gonna set up a few. What underscore diamond. Prove I can spell. Sword underscore netherite. Yes, hello. Why would you do this to me, Max? It's fine, my name's already here anyway. But no. Your comment is being removed so that people watching the stream later do not see. Like, unless they want to, obviously. Doesn't really matter. Okay, so then we need a system to read durability of items. So we're going to go from item durability import item durability. So this is going to load in the dictionary from over here that we defined. Hello, I have no idea how to pronounce your name, sorry. I cannot. No. It's impossible. Impossible for me. Alright, so what we need is we need this to be able to recognize durability. So if identified texture is in the item durability, try read that durability. And it probably isn't even important, but like I just want it to be a thing. Oh, because that way I can actually sort items based on durability, which would be really cool. Yeah, that'd be very cool. I can sort swords based on how much durability they have left. Alright, another thing I need to do is remove the enchantment according to texture. Probably in some sort of miscellaneous texture. Textures, miscellaneous. Enchanted item glint, here it is. I'm going to copy this and then turn it into a transparent texture. Just because otherwise the program won't be able to tell like what a sword is if it's enchanted, because it will obviously be changing texture. Miscellaneous, enchanted item glint, and then we're just going to make this transparent. Alright, so I'm just going to reapply the pack and just check if that worked. While that's loading, I'll continue with this. So we need to crop the area of the slot. So we go in right, plot.png, and we're going to save this, and the image is slot region. Okay, and we're going to reapply the pack just so I can see this. Reapply that one. Alright. And now if we have a sword in the bottom right slot, we should be able to work out what it is. The program should recognize it. Put a sword there. Get rid of those, I'll do that later. And I run the chest single. Open the chest. It's not a chest. That's not correct. There we go. I got 1.5k subs just because, you know. It's quite funny. I can't believe you didn't realize. Alright, but the program now can recognize wooden swords. And if I enchant the sword, / enchant, sharpness 5 or something, I don't know, it doesn't really matter. You can see there is no glint, which is what we want. Because the program now won't get confused by that. If I just run this again, chest single, this one, and open it up, it should see that we have 2 wooden swords. Yes, it can see that. And if I have different durability wooden swords, it shouldn't be confused. So if I have a full durability sword. Okay, so now I have full durability and like a half broken one. And run this again, it should still count that as 2 wooden swords, because all it's actually using is the top half of the texture, because that also ignores the numbers. So now we need a system to recognize how broken a sword is. So I'm going to open up Microsoft Paint and then find the coordinates. So this pixel is 628, XY 628. Okay. So slot region, or variability region, should be the cropped slot region. And then we need to crop this image to this specific position. 728. Why are the pixels offset? Oh, because it's double size. So I can actually resize this first. Do I have to resize it? Probably. No, it should be right. We can probably deal with this. Okay, so this is the area we need to crop out. So this is 628. I'm just going to crop that out. So it's Y and an X. 28. And then to, I guess, that pixel there. 32. Okay, that one, and then we need the one on the X-axis. 6 to, oh, I just did the Y. I did that wrong. This isn't an add-on. I'm actually using Python to take screenshots of the screen and work out durability stuff. XY 30. 6 to 30. 32 and 30. That should be correct, so that should take us down to there, and that one should take us down to there. Starts at 628, and that should be correct. Okay, so now I can save this as the durability region. Now I can save that, and then run this. Hello. Superdo. Alright, it seems to have worked, but I think I have trailing pixels that I don't need. Oh no, it worked. Alright, this is the durability bar. But I don't actually need it to be 2 pixels high. I really only need 1 pixel. Cut that down 1 more. XY, so this one should be 29. Screen chest on this. And there we are. So now I have a 1 pixel tall durability bar. And now what I can do to work out how much durability is left is count how many black pixels there are. And I'm pretty sure it's just 0, 0, 0. This black texture. If Paint would actually let me select it. Apparently it won't, but like, pretty sure that's black. I'll just open it up so I can actually double check, because Microsoft Paint 3D is a bit weird. select that and check the color. It is 0, 0, 0. All right, so now that we have that, I'm not sure how I can count how many items there are. So I'm just going to look at this. NumPy, count number of occurrences in 2D array. Actually, this is a 1D array anyway. There's a, like, it's only 1 pixel tall. It's just NumPy dot unique. NumPy dot count non-zero. Or you could do sum. I think I'll just use count because that should be, oh, that's a list function. Or I can just do count non-zero. I'll do that. Okay. Black pixel count equals NumPy dot count non-zero, and then this will be the durability region equals 0. And I should probably grayscale that. Grayscale that value, yeah. Yeah, I should do that. Let me grayscale it. Durability grayscale. There's that one, there we go. Now, I should be able to print both pixels. And it should be able to count how many black pixels there are. No, it can't because I ran the wrong file. There we go. There are 0 black pixels in the first one, and then there are 8 in the second one. And if I check this, I can actually count myself and see if it's correct. I presume it would be because obviously it's just using NumPy. But like, better double check. 1, 2, 3, 4, 5, 6, 7, 8. There are indeed 8. And this bar is 26 pixels across, meaning if we divide that number by 26, we go durability left equals 26, so that will be black pixel count divided by 26 times 100 is the percentage of durability. We can then print the durability left. And I should probably round this to an integer just so it's nice. Actually, there's no point, that's just losing data. Alright, so now we should be able to see how much durability is left of an item. Run this, you can see there is 30%. Oh, this is the percentage taken. So I should do like 100 minus that. 100 minus this number, I don't need that because multiplication comes first. And now you can see, oh, that's nice. Very cool. There is 69% durability left of this sword. And if I look at it, 41 divided by 59, if I do that, 41 on 59, you can see that is 0.69, and it's a 69%, so that is basically close enough. Obviously Minecraft rounds it to pixels, but like now we can see how much durability is left of the sword. And what this means is that we can actually use this in a system so that we can put all swords less than a certain durability in a chest. So the program could like have a bunch of swords and then like put low durability ones in a chest or something. But like, yeah, I don't know, it's cool. You can do cool things. So it's entirely dependent on what you want to do. But now I need to actually make a system to put items in chests. Alright. This needs to be able to now use the mouse to click items and drag. Alright, first thing I want to do, I guess, would be to move items. Not sure how I would do that though. Like what I'm actually gonna do. I guess I need one function which will move from one slot to another slot. So I'm going to call this inventory manage.py, and this is going to be the actual automation stuff. So .py.gui as pad, because that's what I like to use, just so it's quicker to type. And this is the GUI automation library, which allows you to control the mouse. Python. I'm going to drink some water. Stay hydrated. Okay. Now what we need is we need functions. So def move from slot to slot, from slot index, or first slot index equals 0, or like from slot index equals 0, and then to slot index equals 1, because this is just default. And then only allow empty equals true. So pass. Okay, and then we need to pass here container. Right. Move from slot to slot. So this function needs to be able to take items from one slot, put them into another one. And from coordinates should be equal to container first slot index and then 0, which is actually the pixel coordinates because I'm saving them over here. We are saving the pixel coordinates, so that's what we're going to pass here. So that knows the coordinates, and then 2 coordinates just equals second slot. And then I can do tag.click, or I can actually check if the slot is empty first. So if only allow empty slot, then we need to check. So if container to slot index 1 is not empty, we need to return false, because we cannot put the item there if we want to only allow empty. Basically, if the slot isn't empty, don't allow the item to be moved. And then we need a system, that should be it actually. Allow empty, yeah. So now we're going to go tag.click, and this will take an x and y. So from coordinates 0 plus 10, which is just an offset, so because the coordinates of the slot are actually top left, so I just want to click like somewhere around here. And then we need from coordinates 1 towards 1 plus 10. So what this is going to do is just going to click the slot that we select, and then we just have to click again at the 2 coordinates part. 2 towards. This is just going to click the first slot like this, and then click the second slot like that. But it's going to do it very quickly like that. So it's just going to be able to move them. And we should return true. True. And we can also change the actual values stored in container to basically track where items are being moved without having to re-screenshot Minecraft. So it's just going to track the actual contents of the inventory like this. So container from slot index 1 should now equal to empty. Container from slot index 2 should now equal 0 because there are no items in the first slot. And then the 2 slot index TSI should equal the original one for this first. So this is the first slot, second slot, and then we also need a system to check if there's actually no items in there. So container TSI from slot index 1 equals empty, then we just have to return false because there are no items to move. And if we were to try and move items when there aren't any, I'll show you what would happen. So if we want to move items from this slot to this slot, and there are none here, it will click here, and then click here, and then it'll be holding this, which would be painful, because then we have to, like, it'll just have this item in its hand. Can I do a tutorial on how to make a pickaxe or axe? I guess I can. Yeah. But custom pickaxes and axes are, like, all custom tools are, like, kind of wonky. So I'll have to do some stuff with it, but, like, it should work, mostly. It'll be fine, yeah. I'll try to do that. Okay, one more thing we need with this system. Actually, no, this should be it. Return true. Yes, that will return when it's actually been moved. Alright, I have a feeling this is going to work, but I also have a feeling it might not work. So we now, this slot is 0, this is 27, this is 28. I want to move item from 28 to 0. Then you go for inventory manage, and then we have to call inventory manage to move from slot to slot, pass the slot starter into there, and we're going to move from slot 28 to slot 0, and so that's true, which is obviously the default, so it's fine. And then return value. Just so I can debug this if something goes wrong. Alright, so now I should be able to see if it works. It says false, meaning my function returned a false because one of these equals empty. First slot index must have been empty. I'm just going to display what the issue is. 2 slot index, 2 slot, it's not empty. And then I'm going to also click out from slot was empty, so I can see what the actual issue is. From slot was empty, so it thinks this slot is empty. So clearly it's just getting the wrong index. Not sure why though. Slot index, we're going to enumerate. I just want to debug what it's actually, what it thinks is in the inventory and, like, where everything is. I'm going to print slot index, slot 1, slot 2. Just going to print the slot index, the item identifier, and the count. Run this one. Oh, it's slot 27. Oh yeah, right, that's my bad. That's because integer started 0, so it wouldn't work. Wait, why does it think there's no I? Oh, it doesn't, it's counted down. Alright, that's fine. I'm going to actually change this system to Y first. Run this again. That was a good idea. That was not. I realized that would break stuff. Oh, that's because it was just using the crafting table size. That's fine. Doesn't matter. So some container contents equals that, and we get the diamond and then the iron ingots. So from slot 27 to slot 0. Okay. So this one should move from slot 27 to 0. So if I just let go of the mouse, it clicks over there because it's not actually offsetting it to the Minecraft window, which is an issue. So get off window, coordinates, we need to find out the actual coordinates of this. Screenshot this. Open up Microsoft Paint. Might have a screenshot here. Open with Paint. Just Microsoft Paint. Paste this in. Okay, so now we need to figure out these coordinates down here. So this one right here, this corner pixel. 961556. Just gonna put that in there. 961556. Okay, so now we need to offset the actual position by this value. 0 plus that one, or just like def Microsoft window coordinates y, and then we're going to return x plus 0, y plus coordinates 1. Okay, so this is just going to offset the coordinates for us. Real chords equals that plus 10. Now we need to calculate the real 2 coordinates. Should just be the same, but with this value instead. Okay. I can pass this in to this function, and it should actually be offset to the Minecraft window size now. The size and position. Let go of the mouse, and it almost worked, but it didn't actually click down. Probably just because it was too quick, so Minecraft didn't register. Okay, that's because it's too cool, that's fine. Alright, so now USA me. What? What do you mean? So index should be FSA, FSI, so, and then that. Alright, that's fine. And I just have to add some delay in here. Otherwise, Minecraft doesn't register. I like Open English Junior. What? I'm still confused. Sorry, I'm just not sure what that means. It did work. It moved the diamond. I put the diamond there. Let go of the mouse. It did move it. It put the diamond into the chest. That's very cool. Alright, so that's basically what we need. I also need a system to check what slots contain what items. So you can basically search for items in your inventory or in a chest. So inventory extras, def, which slots have, and then this will be passed in the container. And then item type. And we'll just return a list of x to x in container if x1 equals item type. So now what I can do, this slot, or I should return indexes actually. X count x in enumerate container. So I'm going to return count, which should actually be the index. So I. Okay. Now what we should be able to do is we can do. I'm going to put this here. No, I shouldn't do that. I should leave that there. And I should also put this here. Okay, so I can do inventory extras. So which slots have, and then pass in these slots. And then pass in the diamond identifier. Get the first index of that list. So this will assume you have a diamond somewhere in the inventory. So if I put a diamond over there, run this, let it go, you can see it picked up the diamond from here and put it there. So it worked out where the diamond was in my inventory and then put it in the chest. Very tiring, but it appears to be working. So that's a good sign. Alright, so now I can move items from your inventory no matter where they are. And if I do this, I'm going to make it repeatedly put items into that top corner slot until you don't have any more items in your inventory. So we're going to go thinking how we can do this. With while one, we're going to repeatedly move the item from here. So diamonds equals this value. And then target slot. Target slot should be diamond 0, so that we'll get the first slot that I found with diamonds in it. And then if target slot equals 0, so if it's trying to take from this first slot, obviously there's no point taking from this slot, putting it back in this slot. So if it equals 0, we're then going to say target slot equals diamonds 1, and then to make sure that doesn't error out, we're going to go if length of diamonds is below 2 or below. If length of diamonds equals 1, we can then break, because we know we're done, because we know that all the diamonds are in a single slot. If length of diamonds equals 1, then stop the loop, and that target slot should be correct here. Right, so now we'll let it go. It's spamming, saying 2 slot was not empty. Oh, right, that's because I set this to true. Or this value, allow empty slot, only allow empty, should be false. So it should ignore even if it's not empty. So that was just a silly mistake there. But if I let it go, I double clicked it anyway. So now it's repeatedly seeing it being moved. And I cannot stop this. There we go. There's a failsafe, luckily. In Pyota GUI, if you move the mouse up to the top corner, it closes the program. Alright, so it just keeps saying true, and it was spamming. Probably because it was clicking too fast. I'm going to increase the delay and make it move to there first, and then away from there. And I'm also going to add a time.sleep. It's like 0.5 seconds, just so I know what I'm doing. And I'm going to print the target slot. Just do that. So I know what the program is trying to do. Run this again. and it didn't find, oh, it did find diamonds, but that's because there's only one, so I just closed the stop, it just like stopped the program. Because I thought they were all in one slot, which is what it's trying to do. If I run this, let it go. Ah, I see what's happening. It's not updating the contents of the container. So it keeps thinking that there's one item down there when there's not. Because apparently this doesn't actually edit the original container, so I have to return true and then container. And this one should just return false and none. Oh, container as well. Container. Okay, so this will now handle updating the contents of the inventory. Return and slots should be equal to that. Nope, it still thinks there are items there. For some weird reason. Which slots have? They should be redefining that. Oh. Oh, that was dumb. Empty. And this one should be 0. Alright, I see what the problem was. And then I also need another failsafe check here. So if from equals to, there's no point doing anything, so print from slot is the same as the slot. And then false. Okay, no. Modified slots should be equal to that. And if ret is true, then slots should be modified slots. So now, if this succeeds, it will only update the contents of the inventory. So if it returns false, obviously it didn't change anything, so there's no point updating this variable. So it should be better now. If I run this, let my mouse go. Yes, you can see it's moving it. Taking all the diamonds and putting them into one slot, and now it's done. If I just spread the diamonds out everywhere. Look at that, I had the perfect number. Very satisfying. I should actually be able to remove this and just increase that to like 0.04. See if that works at all. It might just double click. Nope, it does work. Very cool. Hello Ryan. Welcome to the stream. I am making a GUI automation program for Minecraft because I feel like it. Alright, so I'm going to time.sleep there, change that down. Alright, so now it should work really fast. You can see it's taking all the diamonds from each slot and putting them into that one slot in the top left. And it's done now. And it's very cool. And now I need more controllable things. So basically I want this system. I'll be able to tell it to put, like, I can basically run a command which just says like put 4 iron in the top slot. So it'll go 1, 2, 3, 4, and then put the iron back where it was. Just like there or something, I don't know. Wherever it was, it'll just put it back. And this also needs to work if there are multiple stacks of iron like this. So if you have like this, and I tell it to put 4 iron in there, like this, and I want to put 4 iron there, it has to be able to click this, and then just drop that there, and then pick this one up, knowing that it should equal 3 when it clicks here, and then pick this one up, right click and only put 1 in, and then put it back. So basically, has to work out how to add these up to get 4 iron into this slot. And I feel like it should also do it efficiently as well. So I might make it pick up the biggest stack it can find first. So like if I tell it to put 4 iron in, it's going to pick up the 32 and then put 4 iron in and then put that back. And if I do it again, it'll put 4 more iron in, again 4 more, again 4 more. And now these are equal, so we'll pick this one and then do 4, and then pick this one and do 4, and then this one, and then this one, and then it will go like 1, 2, 3, 4, 4, 4, and it should just sort all these out correctly. So like theoretically this shouldn't be too hard to do, but things never work out. So we'll see. Hope this goes well. And yeah, we can also detect durability of items. Alright, so I don't need that anymore. And this inventory manage system needs a new function, which will be able to tell it to move a certain amount of items. Obviously I should delete that. I'm just going to see how quick this works, if it does work. These items everywhere, and see if this thing still works with this without any time delay there. Yes, it does. Okay. Alright. This is going well, surprisingly. Now I'll put all those diamonds there very quickly. Okay, so what we need is we need a new function called def move from slot to slot. We don't want to use this, we want to use move type to slot, type to slot. And then this is going to take a container, a item type, and it also needs to take a slot index, which should be like 0 default slot index, or like 2 slot index with 0 type slot. Okay. I want to work out how many items are currently in the slot that it's trying to move to. So current count. But first we need to check if the slot it's trying to move to is full of a different item. So current item type should be container, 2 slot index, 1. So if current item type is not equal to item type, we're going to print wrong item type in slot, wrong type in slot. I also don't have to return these, I can just return. I should return container. Oh, that's fine. Okay, and then return false and container. So if like there are diamonds, so basically if like 1, 2, 3, 4, if we tell it to move like 4 iron into this slot, it's going to see there are diamonds and be like, these are not compatible. And it will not run this, which is good. So now we need another system which can work out like how many items we need to actually take, and it can calculate stuff. Okay. This will also trigger if the current slot is empty. So if it's that, and current item type is not empty. Alright, so that should be better. This won't cause any false positives. So now we can test this. So target count or current count, where you need to check how many items there currently are. Current count in slot should be container slot index 2, which will check how many items there are currently in the slot we're trying to move items to. And then add count should be equal to move type and count to slot item type item count. So add count should be the item count, which is the target count minus the current. So if we already have 2 in here and we want it to move 4 into here, it should only just add 2. Yep, that's correct. And then we also need to check if add count is below 1 and add count is below 1. We want to move items. And false and container. So now we know how many items we have to add. So print add count. Return true containers, just debug so I can see what's happening. Container, how should it spell? That would help. Alright, so now I'm just going to print the add count as well. And if I run this system, I'm just going to not run that. Just go inventory extras, inventory manage dot move type and count to slot, and this will be slots. Item type will be main ingot. Count will be 5. And 2 slot index will be 0. I want to move to the top corner slot. And then return modified. Okay. Then print return. So I can just see what's happening. So if I run this, add count equals 1, and it returned true because I want to move 5 into that slot, and it only has to add 1 to reach 5. And if I tell it I want to move 5 in there, but there are 6 in here, or there are 7, and run this, it should tell me no. Add count is below 1, do not need to move items. Cool, it knows that it doesn't need to move any items. Alright. So now I can do some cool things. Move item type and count to slot. Alright, so we'll try and move 5 to there. What if I put the wrong type of item in here? It should tell me the item types are not the same. Wrong item type in slot and say no. That's cool, that is what we want. So now we need to work out how to most efficiently move items. Because if there's like 3 here, 61 here, it is kind of hard. It's taking a lot of thinking. I need to drink some water as well. Alright. First things first, I think I'm going to check. So like if I tell it to move 3, and there's 3 here, it's like the most efficient way is just going to be picking up this and putting it there. Like that's quick and easy. It's just 1 move, 2 clicks, 1 single item move. And if there's like 6 here, 7, keep doing that, and I tell it to move 3, what it should do is it should right click this, just to split it in half and then put 3 there. So that should be good. Like that should be the quickest way to do things. So I'm going to set that up. So I guess I can set up a system that should be like I need a system to check how many, like to match how many items are in a slot. Should be inventory extras, def, which slots have count, container, item type, item count. I'm just going to copy this. This will return all slot indexes that have all slot indices that have the right item type and the right item type. So I should be able to just use that. So matching target count slots should equal to inventory extras. Have I imported that? No, I haven't. Import inventory extras dot which slots have count, pass the container, the item type, and the add count, which is the target count, and then that should be it. Yeah. So now if length of matching target slot, target count slots equals 0, do more processing to find what items to move. But if there is one, then we're going to go from slot will be equal to the matching counts index, which is 0. So we'll get the first element. And then we just have to, basically, I think we can just use the move from slot to slot thing. I should just be able to return that. Move this container. The front one should be from slot. One should be to slot index, and this one should be false. Perform the most efficient move possible. Alright, so that should be a debug message. And I think I'm telling it to move 5. I am. So I'm going to put 5 there, and it should grab that stack and put it there. It did. It knew what I had to do, and it did it. Right-clicking 5 splits it into 3. Because right-clicking something rounds an integer up. Okay. That can also be useful for me. So now, if we have that, perform the most efficient move possible, slot equals that. We can then check if there are any matches that have double. So like if we want to move 7, we'll then right click 14 to move 7. So I can check if there are any double matches. So I'll do this. And the item count should be times 2. And then the item type is correct. And I have to check if the length is above 0. I can also rearrange this. I'm going to rearrange this to make it easier to read. If that's above 0, we can then perform this move. Otherwise, we have to continue processing stuff to find the next move. So if it finds the correct count, it's just going to move that. If it finds double the count, it will then have to move that. Guess this should also take a split stack equals false. And the button, it's the button. It looks like peg.rclick, right click. Yeah. So if not split stack, we then have to left click. But if we do split stack, then we get the peg.right click. right click. That'll right click this time. All right. So I should be able to split stacks now. And then if this is above 0, we know there's one option. Second most efficient move possible. The efficient move. My debug messages are very funny. They're kind of just random stuff. So that will be that, and then we have to set this to true because we want to split the stack. And then if we can't do that either, actually I guess because that returns, I can just do this. And that one also returns, so I can just do that. Couldn't figure out a way to reach the target count. To reach the target count. Alright, so now I can probably just remove that. This up here. And if I run this again, I think I told it to move 5, yeah. So if I make it move 7 now, or just double this up, 1, 2, 3, 4, 5. Why do I always do this? There we go. 10 in that slot. Doesn't do anything. From slots, okay. Oh, that's because I typed the wrong number, okay. The wrong variable. It shouldn't work there. If I run this, it's split in half and move 5. So that is exactly what I wanted to do. And if I make it move 32, actually I'll leave it as 5. But like if I do this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and have one item in here, and then have a stack of 8. It should be able to grab that. Like as far as I know, that's what it should do. And yes, it did. It worked out how to get 5 into this slot. But that's a problem, because it doesn't know how to do it if that's like not an option. So like over here, if I have it just as a stack, oh, it thinks that's a different slot because my mouse is over it. Oh, I can't do this. There we go, mouse there. And now it says it couldn't figure out a way to reach the target count. So it doesn't know how to get these to there. And really what it should do, it should just click 1, 2, 3, 4, 5, and then put this back in the slot that it was. Alright, so what we need to do, I can have an else. I don't even need an else. There was no easy way to do this. Pause, which I don't actually need. Now I can check. Basically, I need to work out. Okay. Because like it might also be like this. There could just be 3 iron ingots like this in the inventory, and it needs to work out how to move 3 there. And what it should do, it should move this one, and then this one, and then this one. But it won't do that yet. So moved count should equal 0. And now we need to work out how to find all of the slots that have a below count. Which slots have less count more. Alright, so this will work out if there are less. I need a while true loop, which will just run repeatedly. I can have a moves list, which should just be that. So need this to ignore index. X if I is not equal to index. All right, my brain is currently being fried. This should, okay. Lower slots should be equal to inventory extras dot ignore index, or actually that won't. These just return indexes. Ignore index if that, okay. I for I in indices, indices. All right, that should be better. Ignore index, and then this will be inventory extras dot have count less container item type, and then this should be add count. And then we have to ignore all the indices of the slot we are moving to. So basically this will work out all of the slots that contain an item lower than the target amount. So if we want to move 3, the target we have to add to this slot is 3. So this function should find all of the items that have all the slots that have less than 3 item in them. So we'll find these, but if they were like this, like if it was this, it would return only this slot because this one has less than 3. So now lower slots equals that, and that. Alright, so now what we can do, if length of lower slots is above 0, if there's actually any lower slots, we then have to go index, or from slot index equals lower slot 0, move from slot to slot container. Does this thing return a container? It does. Container from to false, and I can ignore the split stack. And I'm just going to run that once just so I can see what it's doing. I'm currently telling it to move 5 items, so if I just have a stack of 4 and 60, it should grab the 4 and put it there. It did grab the 4. It put the 4 there, and if I also have a 1 there, it didn't do that. Oh, that's because I'm breaking. Oops, it thinks that's a new slot. Okay, there we go. It basically double clicked. 1, 2, 3, 4. I guess there's an easier way to do this. There is an easy way to do this, but I don't want to use that way yet, because that way is less efficient as well. Lower slots above 0. Very confusing. Alright, I'm trying to move 5. So I should see this value. And I need to also track how many I've been moved so far. Or I can just do this minus this value. Add count. Add count minus equals the this value. I hope you're all enjoying watching me struggle. It's very confusing. Add count should minus. It should minus the container from sort index count. Alright, so that should work out how many is currently moved. Yeah, he's double clicking for some reason. I think it's just clicking too fast and it causes it to double click. I should add more delay here. Didn't do anything, which is correct. It couldn't do anything in that situation. And it just moved the items there. Which I guess is good, but like also I need this as well. These function names are becoming so long or same. Okay. Why don't I even need that? I can just do it. Okay. Have count less than that plus 1. So now if we have 2 and 3 and a 1 and a 2, what will it do here? It did it correctly. What if I don't have enough? What if I have like 3 and 1? It'll probably then just put 4 in. 4. What if I have a 1 and 4? It adds it to 5. And then what if I have this situation? Okay, so after we've done all the lower slots, it then works out I can't do anything else. So then what it needs to do, it needs to find the highest existing slot. Actually, we could just, like if there are lots of items here, we could probably just double click and then click a bunch of times and then let them go. And that will put the right amount in. That's no fun. This is the fun, definitely. It's all driving me insane. And now we need to repeatedly find the biggest slot. Biggest slot, or biggest slot should be equal to container item type. Now I need to make this function. Wait, we should be able to sort the container, and the key will be lambda x2. That'll sort them based on count. Pretty sure sorting defaults lowest to highest, so I just have to reverse this. Reverse equals true. And this shouldn't be sorting the container value because that's not correct. Container x4x in which slots have container type. So to basically filter out any item that's not the right type, and then we'll sort every entry based on how many there are. I should be able to print this value if length of sorted slots is above 0. Right here we have to break. Here we have to break. And then we're also ignoring the index, which should be correct. And these aren't actually indexes. These aren't indices. They should be the actual slot. So like the slot data, which is like pixel coordinate, item type, and then, yeah. So an ignore index here would not work. This is very frustrating. And the Minecraft music in the background is not helping. Alright, let's retry this. Every entry in here. Screw it, I'm gonna just do this by hand. No, I shouldn't do that. Actually, it's not that bad. Yeah. Sorted slots equals that. And then sorted indices equals this, and for slot in sorted slots, sorted indices. But they're not actually tracking their own indices. I'm so confused. Actually, it should be fine. Sorted indices dot append container dot index, and we should be able to pass in that. Because container is a list, and then return sorted indices. Hopefully this works. If it doesn't work, it's going to be painful. I'm just going to remove, actually no, it should be fine. Okay, I have 64, 32 and 32 in one slot, and I want 5, because that's what I'm calling here. And it should just print out those two slots, the slot indices. So I should display what it's doing. I doubt it'll do anything. Okay, yeah. Lowers, oh, it's because it's no lower. Don't get any of that yet. I just break after there so it doesn't loop forever. And run this. Sorted equals 27, 28. 27, 28. If I just split that up like so, it should sort them correctly. Oh, that's because there were lower ones, damn it. Okay, from here, sorted is 28, 27, 28, 31. If I move these around a little bit, like that, it should sort them correctly. Sorted equals nothing, because it doesn't need to add anything. I'm just going to remove all this code temporarily. Wait, I need that, don't I? No, I don't. Okay. You should sort them highest to lowest. 28, which is that one, and then 31, and then 27. Alright, sorted this lot, so it works out what order they are based on how many items there are. And then we need to work out largest index, or largest count, sorted, and 0. That's the index of the slot with the largest count of items in it. And then we need to individually move a certain amount of items. So a new function, I guess. I could probably do this right here. Return and container. Okay. And I need to go pack.click, which will pick up container largest count position. I guess that's a need. Okay. Minecraft window coordinates, slot coordinates, and there should be the container largest count 0. They should click the slot with the largest amount of items in it. So I should click this one. So I should still click that one, and then I'm just going to see what it does. So I should just click it, and then that should be it. That should be all it does. Just click the slot. Please do not break. Yes, it works. Alright, so click that. And then after it's clicked that, it has to right click 5 times here. 1, 2, 3, 4, 5. And then put it back. That shouldn't be too hard to implement. Add count. Alright, click count. Click count should be equal to the minimum of either how many we need or how many there currently are. And largest count 2. This will work out how many times it has to click in to actually drop the amount of items off. And then we can go add count minus equals click count. We can also go if add count equals 0, we can break, because that means we're done. It means we don't have to add any more items in. which is great because that means we can chill out after that bit. All right. Add count equals that. So now we have to go. I got move to. We have to move to the coordinates of the new slot that we're moving stuff to, which should just be this, and then passing TSI here. Duration should be duration 0.05. I think that's what I did, 0.06. Yeah, it'll be fine, 0.05. Okay. And now we have to right click the specified amount of times, so right click this position. By the way, I should also do that. Right click, interval should be interval 0.01. I guess clicks, how do I specify the amount of clicks? Can I do that? I don't know, I thought I could, but maybe I can't with this. Because then I can just use a loop and it'll be fine. How long am I going to stream? I'll stop streaming in like, I don't know. I'll stop streaming in like 10 minutes-ish. Just after I just want to get this bit done. And then I'll probably stream again in 2 days, 2 or 3 days, and like continue working on this program. Yeah. Because I've been streaming for 2 hours and 38 minutes so far. So I'll stop streaming at 2 hours and 50 minutes, so that's 12 minutes. And then yeah, that will be done. Right, there is no way to do this right click thing. And I'll loop how many times we need to click, and then just click that many times. I'm also going to open my window because it's very hot at night. Now you get to hear crickets, which is always fun. Alright. We right click the amount of times. And then if click count equals container largest count 2. So if that's the exact amount of items in the slot anyway, then there's no point clicking back. So if it is not, then we have to drop off the remaining items in the hand currently. And then that should be it. Like that. Add count equals 0, then we'll do that. Alright, we'll see if this works. And currently it's not actually updating the container variable, so I'll do that later. But I just want to test if this system works. So it should grab 32. Okay. Slot coordinates. Argument after that must be an iterable. Oh. That's because that's an index. This really should be this system. That. And it should be TSI. And I'm just going to save these variables. So I don't have to repeatedly type them in. Okay. There we are. From coordinates to coordinates. And we just have to click the right amount of times. So if I run this, it should grab the 32 and then click 5 times. And it tried to put it back, but Minecraft registered the click first before the mouse move. That's fine, it just means I need to move this using move to before registering a click. Move to 2 coordinates, duration 0.05. Alright, that should be from coordinates. Now this should all work. We should finally be able to put the right amount of items into slots. So we have 5 there, that's correct. And what I'm going to do is I'm going to do something cool and loop this while one. Actually, first I should update the actual contents of the container when I change it, so that the program knows something has changed. 1, 2, 3, 4, 5. It places them in there. Take them back. Alright, so we have to actually modify the container to change this. So if we need to move the items back, we're going to go container. Or I guess we can just refresh it by taking a new screenshot. Hello, Legendary Ripper. Welcome to the stream. Okay, all we need to do is update the container here. So container, largest count should be redefined for container. Largest count 0, which is the pixel coordinates. Largest count 0. Container, largest count 1, which is the item identifier. And then container, largest, if I can spell, help, largest count 2 minus count, which is how many times we just dropped off an item. So that'll subtract the amount of items we just dropped off into the container slot. And then we need to also, if we don't have any items left, we then have to redefine that to largest count should equal. That is correct, and then it should be empty. No, it's not a mod. I'm actually using it to just screenshot the window. So basically Python's just screenshotting the window and then working out where items are and stuff. So it's all done by like GUI automation. So all Python does is screenshots this area and then calculates, just based on images and stuff, how many items are where and stuff. It's very confusing, but like it works. So that's good. Yes. Yeah, it's not actually looking in the code at all. It's basically just seeing what a person would see. Alright, so largest count is going to set that slot to be empty now, because it knows there's no items left there. And then we also have to count up how many items we just added. So this will be TSI. TSI plus. And that should always be that. Alright, this should be correct. TSI equals that. Alright, let's test this now. So for I in range 3 to 20, we're going to repeatedly add I in there. Target count, set that to I. Okay. And then I'm also going to add a time.sleep to give me some delay. So I can see what's happening. Alright, so now if we run this, it adds 3, it then adds 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I should just do it up to the number I typed in. So you can see now it's actually sharing between the two stacks. It just started splitting them up. And that's correct, it went to 19 because the range function in Python stops before that. So if I said that, that should all be working actually. Like based on what it just did. Okay, I'm gonna do one more thing and split this up like so. Into a bunch of groups of 4. That, there we go. And then I'm gonna loop this to like 30. I can stop it later, doesn't matter. And now I'm just gonna let this do its thing. So I'll put 3 in. 11, 12, okay. It is not doing things right anymore because it thinks that there are way too many items. Stop running. It seems like it updated and then calculated the wrong amount of items. Oh, because they're not actually changing anything. So if return equals true, then that should equal modified slots. Okay. Hello, Blue Fox Kid. Welcome to the stream. Right, this should be correct. Oops, I just opened Spotify. Close that. Alright, open this up. Oops, and I'll split up. Yes, I agree, minor. Okay, I'm going to split this stack up into like this. And now run this again, and it should do it correctly. 1, 2, 3, and then 4. No, it still thinks there are too many. No, I'm not participating in the Bedrock add-on jam. Why am I not? I don't know, I just don't want to. Just because there's no point, like, it doesn't really matter. Alright, so now after each move, I'm going to re-screenshot the screen just to capture new data. Just if the screen changes. Oops, that mouse is there. Alright, so I should move 3. And it doesn't know what's happening because there's a mouse on this slot. Why did that screenshot first? Because this was moved with too high of a duration. Okay, we'll retry this. Oops, I really should have ended the stream already. Just got to finish this bit and then I'll be done. End by 10 and then move in 0.1 seconds. Rerun. Okay, see how this goes. Should move 3 and then move that. Now it's running correctly. 11, 12, 13, 14, 15, 16, 17. 23, 24, 25, 26, 27, 28, and should go 29. Lovely. Obviously this isn't how it actually works. It does do it efficiently. So like if I wanted to set it to 29, So I put this 29 to 30, that will just select 29. Run this. It should just put 29 in. Or no, it doesn't, because it thinks there are. Oh, it thinks it's lower. Oh, I think I see what the problem was originally. Lower slots. I was very confused. I just hit sound, but I realized it's Minecraft sounds. Alright, return value and container. It keeps thinking it's low for some reason. It's an issue with this bit of code. What if I just remove this? Yeah. I'll try that. Could have done that the first time. Hello, nope. Wait, what did it even do? What did that just do? I'm so confused. It was like grabbing them and putting them back. But like in the wrong order. What's up here? I am making a program that interacts with Minecraft GUIs. A little bit wonky currently because I'm trying to figure this out. It's almost working. It's very close. But I will be ending the stream before I get to 3 hours because I don't want to do like another multi-hour stream because that was painful last time, a 5.5 hour stream. So I'll be ending the stream like in a little bit. But I need this to work. For some reason it's being really weird. I can't figure out why it's doing this. Okay, I'm just gonna add like a time delay in here so I can see what's up. I don't think I even have time for it. Okay, we should be able to see what goes wrong now. Let it run, and it should be trying to put 29 items into there. So put that in, then put that in, then put that in, 24, and then it just reached 32. Oh, I know what it's doing. Am I winning? I don't know. Am I? Probably not, judging by the fact that I just had to spend ages trying to figure out why something wasn't working. And then it turns out it was just a very dumb mistake. It should work though, hopefully. Put 8 in, and then it should put another 8 in to make it 16. And then I put another 8 in, and now it should only put 5 in. Lovely. 5. There we go. that seems to have worked. I was very skeptical because I don't know. Seems kind of sus. Not gonna lie. But I believe that worked. Like if I make this one, just spread these out randomly. It's more random. Alright, and I'm targeting 29, so it's going to try to put 29 items into there. And I'm actually going to move this. It's going to put 29 items into the slot at index 1. Run this. It works. 29 items are now there. Flawless. Definitely didn't take me like 100 years to make. And I guess another way it can do this is by right-clicking like a bigger stack. Yeah. Yeah, because it does like that. I guess I should use an algorithm to like determine the minimum number of moves to make it more speed efficient. But I believe that is good enough for now. Next stream I will be improving this and making it able to sort items and stuff, and probably also craft items. Yeah, that should be it though. Let me whip up in Minecraft so I can do a cool outro. Like the other Minecraft Bedrock Edition. Yes, I have been live streaming for 2 hours and 59 minutes. Alright, but this should be all I need to do for this stream. Not bad. Like it ended up working. As far as I could tell. I didn't extensively test it, but that's fine. Oops, I am using the wrong skin. Do not question this. I'd like pig skin, please. Okay, we're gonna do an outro in this world. This one. Oh, there. Okay, that's fine. Do not worry about that. Oh, there are blocks. Why do I have atoms applied in this world? Weird, I don't know. Alright, I'm gonna do this outro here. I love the spam in the chat. This is so stupid. Oh my. Alright. Well, if you enjoyed this stream, make sure to sub and turn the notification bell on so you don't miss the next streams. Because I will be doing more of these coding streams because I enjoyed it. And also I want to make this program better that I made. Honestly, yeah, that's about it. Just also share videos. Feel free to watch my tutorials because that helps as well. So like, just you can go check out my add-on tutorials because those are all good as well. Like, I hope they help you. You know, I make tutorials to help you, and if you want, like, honestly, okay, this is getting very convoluted. I don't know how to say this, but no, I'm struggling. I'm too distracted by these pigs and me. But like, okay. Honestly, just I'll see you in the next video or stream, depending on what comes first. I've been preferring to make streams because they're quicker than making tutorials, because tutorials take hours to make. even though they might only be like 10 minutes long or 19 minutes long or whatever. Like that armor tutorial took me 7 hours. But like, yeah, so, you know, streams are easier. So I guess I can actually do tutorials in streams. But yeah, feel free to request tutorials that you need. Like if you want to know how to do something, feel free to request and I'll answer your questions. And yeah, I'll see you in the next video or stream. So, goodbye.